Hello everyone, today in this video we'll be discussing the fifth module of SE, which is related to software quality. Okay, so there are mainly five topics, and we'll be discussing what are the important questions from the exam point of view. Make sure you watch this video till the end so that you can easily score more than 80% marks in the exam. We'll be covering all the important concepts which you need to know, and please do like and subscribe. It helps me make more videos like this. Without wasting your time, let's get started. The first one is introduction to software quality. Okay, so what do you mean by quality? Quality means how well the project is, right? Software quality denotes how good the product is. Okay, and during the project development there are five places where the quality check is important. So when project starts developing, we'll be starting from the requirement analysis and ending we'll be having the final product. In between that there are many phases present. Okay, so in five places the quality check is very important. So which are those five places? Okay, so first let's discuss how the project is made. First we select the project. Okay, what project is to be made. Then we identify the project's scope and objective, what the project has to do. Okay, that objective of the project is defined. After that, identify the project infrastructure, what are the things needed for making this project. Analyze the project characteristics, what are the features of the project. Identify the project activities, what are the activities that needed to be carried out. Estimate the effort for it. Identify the risks involved in it, and what are the resources, allocate those resources. Review the plan, execute the plan, and then lower level planning and review. Again it goes from here. If any another change is required, any update needs to be done, again it will start from this step. So in steps 1, 2, 3, 4 and 8, the quality check is important. Here when you are defining the scope and objective, the quality check is also important here, because based on the quality the scope and the objective needs to be defined. Otherwise it will be very hard for making any changes and the project will not be of good use. Next is project infrastructure. What infrastructure you are using, that should be of a quality. Analyze the project characteristics. The features should be having a good quality. Identify the project activities. The activities which are needed to be carried out, those should be of quality activities. Okay. And at last, publicize plan. The plan which we are going to make for reviewing, that has to be of the quality testing and checking. Otherwise, you will not be able to get the actual good product which you are planning to make. Okay, so these five places the quality check is important. Software quality is important due to the following factors. Increasing criticality of the software. Criticality means importance. What the software is very important. Why? Because large systems and large organizations are dependent upon the software. So the criticality, the importance is very high. So the quality is important because it should not fail in important times. Increasing criticality of the software, due to that software quality is important. The intangibility of the software. The software which we are using, those we are not able to see it. It is intangible, we cannot take a hold of it, right? So the quality is important to minimize the future risks or errors which come, right? We cannot take an error and put it out of it. We have to have a technique or a deliverable due to which we can check if the quality is maintained or not. That is the intangibility of a software. Accumulating errors during development. See, if the error is caught during the early stage, it can be fixed easily. If the error is not caught in the early stage due to lack of quality checks, what will happen is the project will be developed. After that the error will be found and we have to rework all of this. It will be a waste of time and effort. So earlier we need to calculate catch the errors. For that, quality check needs to be implemented. So these are the three things why software is important. It is the criticality of software is more, it is intangible, and error should be uh, taken very early stage, taken and fixed on in very early stage. Quality of the software can be defined on external factors and internal factors. What do you mean by external factors? External factors means how well the product is performing. What is the performance aspect of the product? How much it is helpful to the customers and the clients and the end users? That is the external factors. That quality they see it from that perspective. Internal factors is whenever a change needs to be happened, if a bug comes or some fixes needs to be done, if the on the development time, the how easy it is to implement the project, understand the project and make changes to it. That are the internal factors. Internal factors is related to developers who develop the project. The quality should be good so that development will be easier for them. And external factors is related to the end users. Okay, quality draft should have the following data. A quality draft is implemented wherein we document all the aspects of the quality which we want in a project. So that should have the following data: definition and description of what quality it is, scale, how much it should cover, what all the different functions and components it should cover, what are the quality checks or the tests that will be performed on it, and what is the minimum acceptable product. If it is lesser than that quality, it will be rejected. That should be defined. Target range means that quality check is covering what all functionalities, and now means what is the current value of the quality. Okay, these things should be defined in a draft which we are preparing for quality. Okay, quality documentation. There are several measurements for the software quality. Now, how do we measure if a product is good or not? Availability, how much time the product is available to use. Mean time between failures. Okay, means if some failure is there, it is for 10 minutes, another failure is for 15 minutes, another failure is for 15 minutes, so total it is 40 minutes, right? 40 divided by 3, it will be 13 or something, right? So 13 is the mean time between failures. That is how much less it will be, that is that much better it will be. Failure on demand. Okay, if it is having a failure on demand, fix should be there. Support activity, the support should be there whenever software is having a bug or the user is not able to understand. So these four things define the quality. The measurements which we are using is availability, mean time between failure, failure on demand, and support activity. Okay, moving on to the second topic, which is ISO 9126. What it is? It is a software model, software quality model. Okay, in software quality model, what we do is we will be defining some standards which will be used for evaluating if a product is good or not. Why this was introduced? ISO 9126 was introduced in 1991. Okay, when it was introduced 1991, to tackle the question of defining software quality. What it is used for? Defining the software quality. What do you mean by software quality? That it defines. It has a set of rules. Based on that rules, we'll be able to know what is actually meaning of quality. Okay, it is a definition of quality. The standards are defined for the following set of users: acquirers, developers, independent evaluators. Acquirers are the end users, developers are the one who develop the project, independent evaluators are the one who just review the product. For them, the standards are defined. What things they should keep in mind whenever they are going to judge a project, to so that it is good or not, it is of quality or not. What are the standards? That is defined by ISO 9126 for the following types of users. Okay, ISO 9126 defines another term, quality in use, and the following are defined: effectiveness, how effective the product is; productivity, to create the product, how much staff was required, how much effort was required, was it less or not; safety, by the project, who all are safe, are the end users safe, are the developers who are creating the project, they were not under some harmful situations, and those aspects are in the under the safety. Satisfaction means both the developers and the users are satisfied or not. If all are good, that means the quality of the product is very good. Okay, ISO 9126 define six major external software characteristics. This is very important. Okay, from the exam point of view, also this is very important. What are the six major external software characteristics? Okay, first is functionality. So just imagine one project, whatever you want in your mind. Just imagine one product, and based on that product, I'll be discussing. Okay, that product, whichever is in your mind, that should have a good functionality. What does functionality mean? Which covers the functions that a software product provides to satisfy the user's needs. So one product is to satisfy users needs. For example, the cab booking applications, what is its function? Its function is to book a cab so that the user can use that to travel from one place to another place. Whether that function is covered properly or not, that is functionality. Okay, so inside that, sub characteristics are there. The sub characteristics, if these are satisfied, obviously the functionality will also be satisfied. So what is that? Suitability, is that functionality's product is suitable or not. Accuracy, is there or not. Interoperability, is it able to operate in different environments. Function compliance, is it able to compliance and fulfill the functionality which it's saying or not. Is it secure or not. These are the sub characteristics which make up the functionality. Okay, second one is reliability. What do you mean by reliability? It relates to the capability of the software to maintain the level of performance. That performance should be maintained, it should be reliable, we can trust that product that it will perform whenever it is needed to perform. So the sub characteristics will be maturity, fault tolerance. It should have the whenever a fault happens, it should tolerate it and rectify it. Recoverability means recovering from the fault or the error. Reliability, compliance means reliability should be maintained. Moving on, we have the third one, which is usability, which relates to the efforts needed to use the software. How hard or how easy it is to use the software. Understandability should be there. The project should be understandable. Learnability, we should be able to easily learn the product. Operability, we should be able to operate the product. Attractiveness, UI should be good. Usability, compliance, the usability perspective should be all of quality standards. Okay, so these are the characteristics, sub characteristics which make up the usability. Fourth one is efficiency. What do you mean by efficiency? It relates to physical resources used when the software is executed. How many physical resources it is using, how much efficient it is. Time behavior, is it using more time or not, is it using more resources or not. Efficiency, compliance, is it complying to the quality standards or not. Fifth is maintainability, which relates to the efforts needed to make changes into the software. Once a software is made, if any error comes, how easy it is for the developers to make the change to it. That is the maintainability. Analyzability, is it easy to analyze. Changeability, is it easy to change or not. Stability, whenever we make a change, other things should not get unstable. Testability, is it easy to test or not. And the quality quality is maintained or not. Okay. Sixth one is portability. Portability means the ability of a software to be transferred into a different environment. Will it work in a different environment or not? Will it adapt or not? Adaptability, installability, will it get installed easily or not? Coexistence with the other apps, replaceability, whether it can be easily replaced or it is hard to replace. And the compliance means quality standards are maintained for the portability or not. Okay, these are the sub characteristics for the portability, the ability to work in a different environment. Okay, moving on to the third topic, which is product versus process quality management. Okay, so product we already discussed, the above things which all the characteristics I discussed, right? That is about the product, how to check if the product is good or not. But the thing is, we need to also check the process is good or not. Why do we need to check the process? See, the above discussion is related to the product quality, and product quality cannot be determined at the early stage. Whenever we are planning if the product is good or not, that will be determined at the end of the project. We can test it and get to know. But before only, how we can get to know? Before only, we cannot get to know by the product quality, but we can get to know by process quality. Why? Because the process, if you are following the good quality process, obviously the product which will be made using those process will be having a good quality, right? That is a common sense. So the same thing applies here. In process, if it is good, the product will also be good. So what are the aspects in process quality management? The following are required for process quality management. Entry requirements, before you start the project, what are the plans you have made, whether it is of good standard or not. Implementation requirements, whenever the product is being made, the process is being followed is good or not. And finally, the exit requirements, whenever you exit, we have to check if there is a documentation for that. How do you maintain it? Is the security provided? Is it performing the features which you had initially decided? All are meeting the quality requirements or not? All those things come under these following. These are checked for process quality. Okay, moving on to the next topic, which is decomposition techniques. Very important. So in decomposition techniques, what we do is we'll discuss some techniques based on which we can access the quality. Okay, before discussing the techniques, let's understand why decomposition here. See, decomposition might be a new term. What does it mean is, it is dividing into different parts. Okay, a main thing divided into different parts, that is called as decomposition. But why is decomposition needed in software quality? See, to obtain a software project estimation, the following are taken into consideration. First is to what I mean is, to if there is a project P1. Okay, there is a project P1, it is of good quality or bad quality. To estimate that, we have to consider four things. First is delay estimation until late in the project, because as early we are in the project, it is hard for us to estimate that whether the project will be of good quality or bad quality. The later in time, it will be more clearer to us that it will be good or not. So always delay until as long as possible, so that we get to know more information about the project and we can make a better estimate. Okay, second is base estimations on a similar project that have been completed. Currently project P1 is being made, but initially project A1, B1, C1 had been made. Based on the qualities of this, if they are similar to P1, we can estimate that P1 will be good or not. Okay, relatively use relatively simple decomposition techniques to generate project cost and effort estimates. So we'll use some techniques, which is decomposition techniques, to generate what will be the project cost and the effort will be required. Okay, this will discuss in detail in the upcoming topic. Use one or more empirical models for software cost and effort estimation. Here we will be using some formulas, using which we will be able to calculate how much cost it will take and how much effort it will take. This also we will discuss in the upcoming topic. Okay, so these two will be discussing in depth. First, let's discuss the decomposition techniques. The following are the decomposition techniques used. First is sizing. What do you mean by sizing? Sizing refers to quantifiable outcome of a software project. When one software project is there, the outcome what I am getting, that outcome is called as sizing. Okay, There are two methods used: direct method and indirect method. In direct method we use LOC, the lines of code which is required to make that project. Indirect method is FP, which is function points. Let's discuss in depth what is LOC and FP. Okay, there are four methods suggested for sizing problem. First is fuzzy logic sizing. Okay, type of application and the environment required for developing the project, that is taken into consideration. Function point sizing, what are the files required, and standard component sizing, what are the components required there, and the quality product standards are there or not. Change sizing, if any change is required, what will be the estimates. Okay, so these are the things which are used to calculate how much outcome we can get based on the following quality. Okay, that is what is called sizing. How much quality we will get based on the input which we are giving. Okay, so let's discuss LOC and FP. Okay, so LOC and FP both come under problem based estimation. This is the first type of decomposition technique. I mean the second one, the first one was sizing, second one is problem based estimation. So here LOC and FP is used for productivity metrics. Okay, how much it is more productive, the product developers are productive or not, making the product good or not. For that we use LOC and FP. Okay, they are different in estimation techniques, but they have many similarities. LOC and FP both are different, but they have similarities. LOC means lines of code and FP means function points. So what is LOC? LOC goes into more levels of detail during the decomposition. Okay, decomposition means one project will be there, we'll be dividing the project into different parts and we'll be going in depth in each part. Okay, again we'll be going in depth, again we'll be going in depth. This is in LOC. It but FP uses does not go into more details, but it uses 14 analyzing factors for each component. Here the project is divided into components or the functionalities. Okay, and each component will be analyzed based on 14 factors. Okay, that is the difference between LOC and FP. Baseline productivity metrics are defined by as LOC divided by PM and FP divided by PM, or the cost or the effort is derived. So what happens is we'll be calculating the LOC and dividing by PM. I'm not sure what PM is, but we'll be dividing it with a factor called PM, and then we'll be obtaining one answer. That answer is nothing but cost or effort which is required. Okay, so let's discuss LOC and FP. An example of LOC will be as follows. To develop CAD application. What is CAD? Computer aided design. Here we will be having a computer and we'll be having to make the different shapes and geometries using the computer. That is called as computer aided design. For CAD application development, each requirement can be translated into number of LOC. Means for CAD application, there can be many different requirements. Like for example, user interface needs to be made, two-dimensional geometric analysis, database needed. So for all of these, we need to have the software apps developed, right? So for this one, it requires 2,300 lines of code. For developing this, it requires this many lines of code. For developing this, it requires this many lines of code. So based on the lines of code, we can estimate how big the project is and whether the project's quality is good or not. So three features are present here and this many lines of code is there. Average will be calculated and it will be compared with the quality standard, whether the lines of code are more or less given the features. Okay, that is LOC. Second is FP. In FP, what happens? Function points are given. Okay, to components, the function points are given. Like for example, here what is considered is in the same CAD application, how many external inputs are there, how many external outputs are there, external inquiries, internal logical files, external interface files. It deals with the inputs, outputs, inquiries, and files. Okay, so here all those things are taken. How many files are required, how many resources are required, that is calculated, and that is the function points. Okay, for the CAD application, there are 320 function points. Okay, an example of process based estimation. This is the next one type of estimation, which is process based estimation. Estimation here is based on the process used, which process we are using, based on that the estimation is made. So here person hours is required for a task. How many person hours is required for completing a task, that is that defines if the process is good or not. For CAD, the total estimated project cost is 368,000 and estimated effort is 46% months. These two metrics are provided by the process-based estimation, and we can judge if the quality is good or not. The next one is estimation with use case example. You know what is use case, right? There will be a chart, flow chart type of thing, and which will be defining one use case. Like first take this, then do this, then do that, and so on. Like in CAD, we'll be having to use the different use cases. Like what are the different kinds of functions possible. We'll be depicting it diagrammatically, and there are three subsystems in that. Okay, how many are there in CAD? Three subsystems: user interface subsystem, engineering subsystem, and infrastructure subsystem. So the whole CAD project is divided on the basis of users interface, the engineering like the geometry and all, and infrastructure use, what are the softwares used. Okay, so for each of these there will be some use cases and the number of pages required for that use cases. There can be use cases as well as the scenarios present inside that, and based on that we will be calculating if it is a good quality or not. The estimation is made based on how many use cases are there and how many pages and scenarios can be generated. Okay, now we have discussed a few the estimation techniques, right? Process based estimation, use case estimation, problem based estimation, and sizing. In this, if many are there, how do we choose which is which is better one for us? Whenever there is discrepancy between the estimates from various methods, means someone is giving a high estimate, someone is giving a low estimate, some process is giving a very low estimate, some process is giving a normal level of estimate. If there are many discrepancies between the estimates, what do we do? The following actions can be taken. Check if the scope of the project is properly understood. What is the scope and objective the project is designed for? Is it understood in all the process or not? Check that. Second is productivity data might be inappropriate. This can also happen. The data which you are using might not be accurate. If you are using outdated data, that can happen. Now based on these two, if you follow, it will be a more accurate one. After that you can choose any of them, okay, whichever suits for your project purpose. Okay, moving on to the last topic, which is empirical estimation models. Now we will discuss some models or the formulas which can be used to estimate the cost and effort. Okay, so estimation model for a computer software uses empirically derived formulas to predict effort as a function of LOC or FP. The formula estimation model, this is the first one. Here we use E is equal to A plus B into EV raised to C. A, B and C are the empirically derived constants. E is the effort in person months and EV is the estimation variable. Plugging in these values for this particular project, we'll be able to calculate what are the person months required. How much person months is required for making that project. PM means person month. Okay, the previous one I said, you know it, LOC by PM. PM means person month. Okay, FP by PM also. We'll calculate the LOC by PM and FP by PM. Next is COCOMO 2 model. What is COCOMO 2? Constructive cost model. Okay, constructive, how much cost it will take. It is a hierarchy of estimation model that addresses the following areas. Application composition model. Okay, what is the composition of the model? What are the things included in the model? What are the applications we can get from that model? Early design stage model. This is the second type of model. We will be having a design at the early stage. And post architecture stage model. This is the model where we will be having, after the model is made, we will be having a post architectural stage. We will be analyzing what are the different estimates required after the project is made. Okay, the last one is software equation. Software equation is a dynamic multivariable model that assumes a specific distribution of effort. Distribution of effort means which projects, how much things are required for that, and what are the efforts required in those things over the life of a software development project. Okay, so here we use E is equal to LOC into B power 0.333 divided by P cube into 1 by T power 4. E is the effort in person months, so we get effort in person months or person years. T is the project duration in the month or year. If you are calculating for month, if you are calculating for year, it is year. B is the special skills factor. We will be calculating the skills required for that particular project and putting into an equation a variable called as B. And P is the productivity parameter. Based on the productivity, we will be calculating. LOC is the lines of code required. If we put the values based on that project, we'll be getting the estimate of how much person months is required for completing that project. Okay, so that's all for this video. If you found this video helpful, please do like and subscribe, and thank you so much for watching. I'll see you in the next one.